So, hello friends. Welcome back to my channel. So, in this video, we are going to learn physics 12th standard physics optical chemistry chapter for that is J means steady material. So, that I'm going to explain. So, the topics that we are learning in this chapter, the most important topics is about the human eye. We are going to learn and about the microscope and the telescope also we are going to learn in this chapter. So this is the diagram of human eye. So the first one is, let us see, the first thing is eye lens. So it is a overall behaves, it is like a behave eye lens, it is like a convex lens of mu, that is 1.437, it is the value. Now the retina. So retina, it is a real and inverted image of an object. So retina, it is a real and inverted image of an object that is obtained at retina. Brain sense it erects. So the brain senses it erects it and it shows. And the yellow spot that you can see in the diagram, it is the most sensitive part. The image formed at yellow spot is brightest. So the image that forms the yellow spot of the eye, it is very much brightest. Next, the blind spot. So optic nerves never goes to brain through blind spot. It is not sensitive for light. So the blind spot, from there is blind spot. So there is light does not passes from that nerves, from the optic nerves. Next is ciliary muscles. So eye lenses is fixed between these muscles. Its both radius of curvature can be changed by applying pressure on it through ciliary muscles. If the eye lens is fixed between these muscles, between these muscles, the eye lens is fixed. So we can change. So we can change the radius of curvature by changing the means by applying the pressure on this ciliary muscle. Next, power of accommodation. It is the ability of eye to see near object as well as far object. It is the power of accommodation, we can say it. So these are the things about the eye you have learned. And next is the range of vision. So the range till how much distance a person can see. So the for an healthy eye, if the eye is good, a person can see 25 centimeter near point. The near point is say 25 centimeter, and a far point is infinity. How much far only? How much far you can see very far? Okay. So a normal eye can see the object clearly only if they are at a distance greater than 25 centimeter. Okay, and this distance is called as the least distance of distinct vision, and it is represented by the value by d. Next is the persistence of vision, that is 1 by 10 second. So if time interval between two consecutive light pulses is lesser than 0.1 second, I cannot distinguish them separately. Okay, so if the interval between two consecutive light pulses, if the interval that between two consecutive pulses, it is lesser than 0.1 second, the eye cannot distinguish between that light pulses. Okay, now binocular vision. So the seeing with two eyes is called the binocular vision. Next is resolving limit. So the minimum angular displacement between two objects so that they are just resolved is called the resolving limit for eye. It is the 1 is equal to 1 by 60 degree. So this is the It is a how we can find the resolving limit. So it is the minimum angular displacement between two objects. It is the minimum angular displacement between two objects, so that these two objects, they are just resolved. They are just resolved. It is called as resolving limit. Now, specific example: if a person wishes to distinguish between two pillars located at a distance of 11 km, what should be the minimum distance between the pillars? So as the limit of resolution of the eye is 1 by 60 degrees, so 1 by theta is greater than 1 by 60 degrees, so that is equal to d by 11 into 10 to the power 3 greater than, so they into 1 by 60 into pi by 180, that is equal to d diameter greater than is 3.2 meter. It should be greater than 3.2 meter, so that a person can see the two pillars correctly. Now we have seen what are the things in the eye. Here we are there: nerves, retina, and other things. Now, defects in eye we can see: the myopia and hypermetropia. These are the defect in the eye. The first defect is, that is the myopia. Let us see that. Myopia, it is short sightedness also, we can say. That is, the distance objects are not seen clearly, but near distant object cannot be seen clearly, but the nearer objects are clearly visible. So for a person, if he cannot see the distant object clearly, but he can see near object very clearly, then we can say that he has myopia or short sightedness. The image of formed before the retina, this you can see here. So here for myopia, for him, the far pointer distance, it comes closer, so therefore he cannot see it correctly. The reasons for this is focal length or radii of curvature of lens, it is reduced, or power of lens increases, and the distance between eye lens and retina increases. So the distance between the eye lenses and retina, it increases. How to remove this? How to resolve this? By using a concave lens of suitable focal length. By using a concave lens, or by using the glasses of concave lens that have suitable length, focal length. Focal length, if a person can see up to distance, that is sum of distance x, and the focal length of the used lens is f is equal to minus x, that is equal to f minus defected far point, how much far he can see, he cannot see. So a person can see up to distance, that is x. So wants to see distance y. So y. So for finding the focal length, so f is equal to x by y by x minus y is the formula they use, and they give you the spectacles that have the negative. You can see the people say, for me short sightedness is there, so therefore I use the spectacles that have minus 0.51. This is the power of the lens, their spectacles, they say. So that is how, by this using this formula, they find that this much value of lens they have to give, this much sight of lens they have to give. Now hypermetropia, that is long sightedness, if we see, the distant object are seen clearly, but nearer object are not clearly visible. So the distant object, they can see the distant object clearly, but the objects that are near to them, they cannot see the nearer object clearly. So the image formed behind the retina, you can see, by which they cannot see the nearer object, Now the near point moves away. Here, the near point it moves away. The reason is focal length or radius of curvature of lens. It reduces or it means it increased, or the power of lens it decreases. So that's why here they cannot see the nearer object, but they can see the distant object in this hypermetropia. Hypermetropia. Okay. Distance between eye lens and retina it decreases. How we can remove it? By using a convex lens. So the focal length of the convex lens it should be a person cannot see before the distance, that is d. So therefore we want to see the object place at distance d. So therefore f is equal to small d into capital D by d is small d minus capital D. And some other problems are also there, eye defect also there, like presbyopia. So it is the defect that both near and far objects are not clearly visible. So it is an old age disease, and it is due to losing power of accommodation, and it can be removed by using biofocal lens. They use the old age people they use to the spectacles that have biofocal lens. So therefore they can see both far and near distance little bit, not fully. And another eye defect is also that is astigmatism. That is, in this defect, I cannot see horizontal and vertical lines clearly. Simultaneously, it cannot see horizontal and vertical lines clearly and togetherly. I cannot see both horizontal and vertical lines. It is due to imperfect spherical nature of eye lens. So this defect can be removed by using cylindrical lens, that is toric lenses. By using these lenses you can remove this defect. Next, after learning about eye and its defects, the next topic is about microscope. So it is an optical instrument that is used to see very small object or minute object also, you can say, to see that it is optical instrument is used. Its magnifying power is the magnifying power of this is given as m is equal to visual angle with instrument b by visual angle when object is placed at least distance of distinct vision, that is a. So a simple, this is the formula we use to find the power of microscope. No, that is simple microscope. It is a single convex lens of lesser focal length. So a microscope it has single convex lens that of lesser focal length. And also this is called as this small microscope. It is also called as magnifying glass or reading lens, you can say. This is the image virtual and in enlarged image. You can see the enlarged image, you can see the virtual image, that is in the line, straight line, and the dotted line is the enlarged image. So the magnification, so when final image is formed at t, so when t a final image is formed and infinity, md is equal to, the formula is md is equal to L plus d by f max, and m infinity is equal to d by f min is the formula used to find this uh, mm, simple microscope or the magnifying glass or reading lens value. Now compound microscope that we use in your biology laboratories, it is used. So compound microscope it consists of two converging lenses that are called as objective and eye lens. So for if eye lens is lesser than f objects and diameter eye lens is lesser than diameter of object, so finally image is magnified. It is virtual, magnified, virtual and inverted. Now that is mu naught is equal to distance of object from object O. That is V naught is equal to distance of image AB that is formed at the objective from objective, that is mu E. So this is the formula that you use. MD is equal to minus V naught by mu naught bracket 1 plus D by FE, that is equal to F naught by mu naught minus F naught bracket 1 plus D by FE, that is equal to minus V naught minus F naught by F naught into 1 plus T by Fe. This is the formula we use. That after that formula it becomes M infinity, that is equal to minus V naught by mu naught into D by Fe, that is equal to minus F naught by mu naught minus F naught D by Fe, that is equal to minus V naught by F naught into D by Fe. So the length of a tube or distance between two lenses is LT is equal to V naught plus mu UE is equal to U naught into F naught by U naught minus F naught plus Fe into D by Fe plus D is the formula we use. So here you can see where is mu naught. So mu naught is the distance of between from object to the first lens, and we know unit is the distance between object, means the first lens to the lens that is inverge this one, and ue is the distance between the a point that where object is two lines are colliding, that point to the second lens. So this you can see. Now when final image is formed at T, the formula is L infinity is equal to V naught plus Fe, that is equal to mu naught into F naught by mu naught minus F naught plus Fe. This is the formula we use, and it's also some more formulas you are use sometimes. Now the another topic is resolving limit and resolving power. So in reference to a microscope, the minimum distance between two lines at which they are just distinct is called the resolving limit, and its reciprocal if we call it as resolving power. So if in a microscope the minimum, it is the distance between two lines, the distance between the two lines at which they are just distinct, then we can call it as resolving limit, and the reciprocal of this is called as resolving power. Now RL is equal to wavelength by 2 mu sin theta, and RP is equal to, that is resolving power is equal to 2 mu sin theta by wavelength, that is so RL. So as I said, resolving limit, its reciprocal we say it as resolving power. So therefore RL formula is infinity by 2 mu sin theta. Its reciprocal is 2 mu sin theta by infinity. It is means 2 mu sin theta by wavelength. It is the resolving power of the eye. Means resolving power formula. Here wavelength of light used to illuminate the object, that is beta. Now mu is the refractive index of the medium between object and object and the thing objective that reflects, and theta is the half angle of the cone of light from the point object. It is half angle cone of light from the point object, theta is. Now eye lens, after that telescope microscope. Now let us see about the telescope that are used by the astronauts. Telescope. By telescope, distant objects are seen. By telescope, the far objects are seen. That one is in that one of the there are many telescope. In that one, first one telescope is astronomical telescope, that is used to see heavy heavenly bodies. So far object is lesser than far eye lengths, and d object is distance object is lesser than distance eye lengths. So intermediate image is real. It is the intermediate image that we get. It is real, inverted, and small. The final image that we get. It is virtual, inverted, and small. This is the image we get here. Magnification MD is equal to minus f naught by fe, that is 1 plus fe by d, and m infinity is equal to minus f naught by fe. This is the formula. Now magnification, that formula is ld is equal to f naught plus ue is equal to f naught plus fe into d by fe plus d, and L infinity is equal to f naught plus fe. This is the length formula, and that is the magnification formula, you can see. And here in this image you can see where from where to where it is f naught. So from the first object to the point which collides, it is f naught, and from point that we meets from there to the second object to length, it is mu naught, and ve the whole line. After this, the another telescope is terrestrial telescope. It is used to see far off object on the earth. On the earth we see far objects. For seeing that, it is terrestrial telescope is used. That is, the it consists of three converging lens: objective, eye lens, and erecting lens. Its final image is virtual, erect, and smaller. Okay, the final image that we get after passing light is virtual, erect, and smaller image we get. Its magnification value is MD is equal to f naught by fe into 1 plus fe by d, and m infinity is equal to f naught by fe. Length is LD is equal to f naught plus 4f plus ue is equal to f naught plus 4f plus fe into d by fe plus t, and L infinity is equal to f naught plus 4f plus fe is the length value for terrestrial telescope. Finally, the Galileo, another one is Galileo telescope. So it is also a terrestrial telescope, but of much smaller field of view. So there in Galilean telescope we used three lens, right? Here only two lens. So object is converging lens, while eye lens is diverging lens. So object is converging lens, one converging lens and diverging lens you are using. Here three were also converging lens only. Magnification of MD is equal to f naught by fe into 1 minus fe by d, and m infinity is equal to f naught by fe is the formula for magnification, and length is LD is equal to f naught minus ue, and L infinity is equal to f naught minus fe. This is the for length formula. Finally, the resolving limit and resolving power. So it is the smallest angular separation, that is d theta, between two distant objects whose images are separate in the telescope. This we call it as resolving limit. So resolving limit is d theta is equal to 1.22 wavelength by a, and resolving power, it is 1 by d theta is equal to a by 1.22 wavelength, that is equal to resolving power infinity 1 by wavelength, where a that we use, it is apparatus of the object. And the another final thing is the binoculars that we use. So if two telescopes are mounted parallel to each other so that an object can be seen by both of eyes simultaneously, the arrangement we can say it as binocular. In a binocular, the length of the each tube, it is reduced by using a set of totally reflecting prism. So the length of each tube, it is reduced by using a set of totally reflecting prism, which provide intense erect image, which gives us erect image from erect image free from lateral inversion. From lateral inversion, it gives us erect image. Through a binocular, two we get two images of the same object. We get two images in the due to this binocular. And binocular vision gives proper 3D image. It gives us proper 3D image. You can see in this diagram of binocular. So these are some of the things you can learn. So in this chapter, some of the other concepts, also small concepts, you can learn by seeing these only. Okay, friends, these are the topics, important topics of this optical instruments chapter, physics. So okay, friends, I will see you in my next video explaining some other chapter. Till then, take care. Have a nice day. Bye, my dear friends.